I'm Ethan Kwan, and today I'm going to be showing you how small atoms are. Spoiler alert, small, 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 small. Okay, so here's a diagram of a marble. Not a marble, an atom. And this is the Bohr model. And as you probably come to expect, this is entirely incorrect, but anyway. So let's say this. One sec. So how small are atoms? Well, if you look at a human, and you zoom in onto the head, and look at a single human hair, that human hair is about 500,000 atoms wide. And your hand has 7 billion atoms in it. In other words, if each atom was the size, well, let's just wait for this animation. Okay, if each marble was equal to the size of each atom is the size of a marble. Why do I keep saying marble for atom? Each atom is the size of a marble. How big would your hand be? Well, about the size of Earth. Okay. So this is an atom, and we are going to be using this model just for demonstration purposes, and it's really easy to animate. So we're going to be using this model for now, even though it's incorrect. Okay? Okay. So atoms are made of 3 parts: protons, neutrons, and electrons. And the sizes are completely wrong. Okay, and the protons and neutrons make up the core of the atom. They join together and make up the core of the atom based on the strong force. It's one of the 4 fundamental forces: gravity, electromagnetism, weak force, and the strong force. Okay, and the electrons go in orbits around the atom. Of course, this is of course incorrect, but we're going to be using this model for now, okay? Okay, there we go. The electrons travels at a speed of 2,200 kilometers a second. I guess you could kind of imagine an electron having a speed, but it's not. This is technically a lie, so don't trust this, okay? You can trust the video, just don't trust this 2,200 kilometers a second. By the way, 2,200 kilometers a second, if you're wondering how fast that is, well, this will give you a illustration. It will be as fast enough to go around the Earth in 18 seconds, which is fast. Okay, so 99.99999999999% of an atom is mostly empty space. And that golden part down there in the side, the bottom right, that is all the protons, neutrons, and electrons. Mostly protons and neutrons, because the electrons don't take up that much space. So to imagine how much space there is in an atom, or in an atom, yeah. Let's take the entire Empire State Building and remove all the spaces between the atoms. How big would the Empire State Building be? Answer: the size of a grain of rice. And I had to draw this grain of rice. Okay. Of course, so if our atom does not look like this, just because we just want to know, if an atom doesn't look like this, hello? I'm getting dizzy. This is wrong. What do atoms look like? Well, something like this. So these shells aren't actually the electrons themselves. They're called lumps of probable electron locations. So if we have this atom here, the farther out you go, the less probable you'll find an electron there. But of course, it's not going to be ever 0. It's never going to be 0. It could be super close to 0, like 0.000000000, 0.00001%. That's the probability. It could be that, but it's still not 0, right? So that means, in theory, you could find an electron all from its proton or its atom, all the way across the observable universe, or maybe even across the Earth, or something like that. Okay, so what do these mean? Well, these shells, what they're called, is where you probably will find an electron. So probably you find one here. Maybe you'll find one here, but probably not. You're gonna find one here. You're probably not gonna find one there. Okay, wait a second. If all these tiny things make up the entire universe, but you don't need 100 types of atoms to make 100 elements. For example, just put one proton and one electron together, you get hydrogen. Right? You get hydrogen. Hello? Hello? Yes, you get hydrogen. Add two neutrons and a proton and one electron, you get helium. 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 It's the stuff that goes in balloons. Helium. Helium. I don't know why I'm singing that weird song. Okay. So, add a few more, you get carbon. This is carbon, just saying, just because we like carbon, okay? Carbon, 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 bah, 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 bah. It's a tongue twister. Say it over and over again. Carbon, 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 da, ba, da, ba. Add a few more, you get fluorine. Fluorine, 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 fluorine. It's also a tongue twister. You can say it over and over. I don't really care. Fluorine, 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 blah, 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 blah. I can't say it. Add a few more, you get gold. And yes, I did count out all the electrons and atoms, yes. And I really love the animation. Right? Don't you? It's so cool. Well, the electrons look so cool. Didn't you think so? It looks really cool. Well, I think so. Let's try it again. Whee! Ooh, are you getting dizzy or is it just me? Yawn. Yeah. So that is gold. Okay. This is fun, but it can't keep up forever. Come on, just end. There we go. Perfect. Okay. So, by the way, all hydrogens are the same, even if they're all the way across the universe. That means the hydrogen in your body is the same as the hydrogen in the sun. Okay? Just because. That's how the universe works. Okay? Okay. When is this? Okay. The model of the atom has changed many times. For example, the first one, the one in the upper left, is basically a big sphere. The next one, the one to the right of it, that's the cube model. And then there's the plum pudding model. There's no, seriously, that's a model. The next one from that, the one to the right of the cube, is this kind of plum pudding model. And then the next one, with the one in the bottom left, that is the green egg, which is really gross. No, just kidding. That's also a model, but this time it has a common center. And then there's the Bohr model, of course, which we talked about today. And then there's the quantum mechanic model. Okay, so this video was helped. Well, I learned all these facts from Kirkazat. Kirkazat is a great YouTube channel for learning science, looking at what-if situations. It's awesome. You should go check it out on YouTube. It's called Kirkazat. Okay. Otherwise, remember to hit the thumbs up button, subscribe, and share this channel with others. And also hit that bell thingy. Just so that other people can find this, I guess, YouTube channel. Ding! Okay, sorry, I'll stop playing with the bell. Okay, so thank you for watching. See you at howtodothing.com, and see you next time. Bye.